All right, big day, big day. This is where we go from using the unit circle to trusting the patterns that we see and using those patterns to identify all the angles that satisfy a condition. So in our life, we're going to model some real life situations and there's going to be some sines and cosines in there. And we're going to ask ourselves the sine of what will make this happen? The sine of what angle will make that happen? And the angle measure is going to take on different meanings in application. Like most of the time it's time. So you're going to replace that theta and that angle is going to kind of represent time. So you're going to be able to solve for when does a certain situation happen. Like when the tide comes up and it's at a certain tide, that means it's safe to use a boat in this certain situation. So we know that it happens every 12 hours. So we can find out the first time, we can use that information and find all the other times. So that's the seed I want to plant. All right, what you're looking at here is a couple pictures. Uh, just really trying to make sure that you associate sine with the y coordinate, x with the x coordinate, and tangent sort of that weird opposite over adjacent, so it's a little harder to recognize. But here, if we have a sine of some angle equals a, well, that means the y value here is a. The y value here is a. I'm actually going to go this color. Uh, but that's not the only angle that gives you that y value. The other one is over here. So we kind of have this situation. Those are the two angles that give us the same y value. And you might notice there's symmetry about the y-axis there. Cosine. Here's the second angle that gives us the same x coordinate. I know one's above, one's below, but they both have the same x coordinate, and that is w. Okay, so there's that angle, and we have a second angle. And that one is reflexive about the x-axis. Now what's cool about this is tangent. If we say the tangent is equal to a over b, a number, it's a number over a number. So that's the opposite over the adjacent. So that's a over b. Well, this is negative b and negative a. But when you take negative a over negative b, you get the same value. So the other angle is actually always going to be straight across, or maybe at 180. So those are the sort of things, hopefully by doing these problems over and over again, you kind of are starting to recognize that. All right. There are a ton of identities out there, and identities can, I mean, if I gave you the Trig identity book, it's like 30 pages long and they all have little sections that look like this. And so it's kind of overwhelming because you have no need for them right now. It's like, okay, great. Um, but so let's look at one of them. Let's just look at one of them just to kind of walk you through why this works. So I've kind of outlined this one right here. What it means is that, do you believe it, first of all? Well, if I pick any angle theta, I know the sine of theta is going to be that y value. Great. Now the 90 minus theta, or the complement of theta, because if theta is 20, 90 minus 20 is 70, 20 and 70, complementary angles. And if I graph that, you'll notice that these two triangles are similar. And so this length here is going to be the same as this length, and we'd say that's the cosine of the other angle, or 90 minus theta, or the complement. Neat. Maybe you're in an algebraic situation and you have sine of 20 plus cosine 70, and you really want to combine some things. This is where it's just fun to watch people that are good with identities. They're like, oh, but I see a relationship. Remember that the sine of theta is equal to the cosine of 90 minus theta. Yes, you do get good at this, and you do recognize these things if you use them every day. You're not. I'm not saying you need to recognize this or use this right now, but I do want you to know that they exist. And so 90 minus 20 is 70, and then all of a sudden you can rewrite that as 2 cosine 70. So these are identical. And that's kind of why you use these things called identities. They're identically equal to each other. All right. So you've been given a lot. I'm trying to pare it down today on what you really need. All right, so in general, this is 8F, and we're going to be finding angles. So we're going to be finding all the solutions that satisfy the information. So if we had the sine of some angle is equal to 1/2, I would be really interested in knowing what angles that would be. And you're like, ooh, 1/2. So you look on your unit circle, maybe you could see those. Now, if I say all of them, there's a lot, right? You know, the sine of that's 30 degrees. Well, what about 150 degrees? So there's those two. But then couldn't you add and subtract 360 degrees from those over and over and over again? That's all there's to it. So step one, find the two critical angles. Just like the pictures, there's really like two that are really important, and then we base all the other ones on those. Um, hey, if it's a unit circle problem, if we have exact, don't shy away from knowing that there you have some, the 1/2, square root of 3 over 2, square root of 2 over 2. Those, use your unit circle, become fluent with that. If it's not a number like that, then maybe it's sine of theta is equal to 1/4. Well, that's not one of those values, so this is where we're going to use our calculator. Get the first angle, and then we're going to use a trig identity to get the second angle. Okay, so once we have the first angle, we're going to do something special to it to get the second angle. Once we have the second angles, then we're going to find all the other angles using what we call the period. The period is the time or the length of the x-axis or the amount of angle that it takes to repeat and get back to itself. What we're used to right now is 360 degrees. We'll just go with that. That will be, we can manipulate that a little bit. So we'll add or subtract 2 pi if we're working radians, 360. All right. So the idea is set. Let's go put it in action. These are the 3 formulas that I want you to write down in your best handwriting. And what it does is it tells you how, if I have one angle that works, what can I do to get the other angle that works? You're going to see other things written. I've kind of made them nice and light. They're neat and all, but it's not something we use all the time. The 1, 2, and 3 are something you want to have. So pause it, write those down. I did put subscripts there. That's me thinking. Hopefully it works for you. You can go ahead and pause it and write those down. All right. Hopefully you have those. Now let's go put them in action. All right. Woo. Okay, I went too far. All right. Okay, I've got 3 problems, one with cosine, one with sine, and one with tangent. We're going to do 6 examples, and then I throw another 3 that you can get from the notes. So here we go. All right, cosine of 1/3. I noticed that drawing a picture kind of helps me like think about it, but absolutely do not have to, and it's a waste of time later. But just to make sure we're all on the same page, the cosine is the x coordinate, so we're saying this here is 1/3, and there are 2 angles that have a 1/3 as a x coordinate. So we're after those angles. So first of all, we notice that it is not an exact value, so we're going to use our calculator. We get our calculator and identity. That will help us get the 2 angles. All right. All right, so we take cosine of theta equals 1/3. We do the inverse cosine. They wanted the angles between 0 and 360, so we are in degree mode. So 70.5 degrees is our first angle. Awesome. I don't think that's going to jump around all day. That's neat. All right. Um, so we're going to use our one of the identities that said, hey, you can find the relationship is the 360 minus. So to get the second angle, I take, oh my God, 360 minus the first angle, and I get my second angle. Ladies and gentlemen, this is because cosine. Sine is different. Tangent is different. You have to organize your thoughts there. All right. So as you can see, I've got my two angles. Probably going to jump again. Yeah. I've got my two angles, and they are here and here. So I know this one works and I know this one works. And then I can add or subtract 360. This is going to be written in many different ways, but all it's just saying is you can add 360 k times. So 1 time, 2 times, 3 times, 4 times. So that's what that k stands for. A lot of times they'll just say plus because k can be a negative number, and that means you're subtracting it. So this is the list of all solutions right here. So sometimes you're asked between 0 and 720. Well, certainly 70 and 289 will work, and then add 360 once, you'll get another number, add 360 to this, get another number. So there'll be 4 solutions between 0 and 720. All right, this is the same process every time, every time. So let's look at the second one. Sine of theta equals 3/4. What am I saying here is the y coordinate is 3/4. Well, there's 2 points on the unit circle that have a y coordinate 3/4. Here we go. Whoa. I'm just going to get rid of this. There we go. All right, so the sine of 3/4, it's not an exact value, so I use my calculator and use degree mode, so I get my first answer, 48.6 degrees. Since I'm using sine, I'm going to use this identity, which means if I know the first one, I can get the second one by taking 180 minus the first one. So 180 minus the first one will give me the second one, so I get my second answer. Those are the two critical angles, and now I am done. I need to add and subtract the period, and the period of cosine and sine, just regular functions, are 360. Yeah, wait a minute, that easy? Yes. You just got to believe in it. You got to believe in those values. All right, let's go here, 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 and delete. Those things are not working. I'm gonna have to move me. Whoa. Myself up there. All right. So the tangent of 2, I take the inverse tangent, I get the first angle. The identity, it means just add that, take that angle and just add or subtract 180 degrees. Remember that picture where you had the A and the B? All you have to do is go 180 degrees and you replicate that triangle. So if we had 63, we add 180 and we get our next number. Could we subtract 180? Absolutely. We would just get the same angle but coming from the other side, a negative instead of a positive. So it doesn't matter. As long as you have your two base critical angles, then you just add 360 to both of those, and you will by adding 360 over and over again, you'll create that list of all those angles. Now, special for tangent only. You can, since it's 180 and 360 and they kind of overlap, you actually can get by with this with just taking your first angle and adding and subtracting 180 over and over and over again. You will get the 243.4 on your way. I'm just saying this method is the same as sine and cosine, so it's consistent and people like consistency. All right, let's try another set. So this sometimes things don't work out just all perfect, right? So what do we do? Let's move this over here for right now. So sine of theta equals negative 0.4. Great. So once again, it's not an angle I know. Just going to get rid of this so it doesn't. So we're going to, just like before, take the inverse sine, and we get negative 0.41 degrees. So your calculator's going to give you this angle right here. Now, I wrote it in degrees because we're not used to radians as much. So I just wanted to have you have that little connection. The question's asking for it in radians. So I put my calculator in radians and I get negative 0.41. Great. So now we're going to use our really cool identities. Remember, if we're working in radians, we're going to subtract it from pi to get the second answer, or if we're working in degrees, we'll subtract it from 1/8. And this is for sine. So you got to know there's 3 different ones: sine, cosine, and tangent. Only 3, right? Come on. So we know the first angle is negative 0.41. We subtract it from pi and we get 3.55. If we were working in degrees, we would subtract the negative 23.6 and we get 203. Okay. So I will tell you that the answers are supposed to be in between 0 and 2 pi. Our first answer is actually negative. So we're like, dang it, that didn't quite work. That doesn't fit. Remember, it's an angle that works. It just doesn't know that you're only looking for this range. So how do we create all the other ones? We just add 360 or add 2 pi. So don't throw it out. We use that. We're going to add 2 pi to it to get the kind of the same location, but in a different method or a different a look. So we got to be careful. This is not going to work. Our focus is on that. So what do? We just add the period, 2 pi. So we take our negative 0.41, add 2 pi to it, and we get 5.87. That's going to work out just great. We already have our 3.55. Those are going to be our 2 angles between 0 and 2 pi that gives us those 2 looks. So my solutions are going to be, my 2 solutions are going to be this. And if we did it in degrees and you were following, we get this. Just to show you on the picture, remember before we had a negative angle? Well, by adding 2 pi, we got this angle. Do you see how it's the same position? It's the same one that we're after. So yeah, if you're starting to nod your head like, wait a minute, this is pretty slam dunk. If I know these 3 identities, you are totally correct. All right, let's look at the second example. I'm really trying to hit all possible, places where things can go wrong. So I'm going to go a little faster here. Cosine theta equals negative 2/3. I'm going to get the first angle by taking the inverse cosine. I get 2.3. I know we're not used to that. That's the number of radians. Remember, there are pi radians, 3.14 in 180 degrees. So 2.3 sure does look like this angle. I like that. For cosine, we take 2 pi minus the first angle because I look it up on my little reference sheet. This is not you'll memorize it maybe out of usage, but just have it there. And we get our second solution. And then are they both between 0 and 2 pi? Well, they sure look like it. So we're done. We're done. If we did it in degrees, inverse cosine, subtract from 360, both are between 0 and 360, and so we're done. All right. I know. It's like, come on, Sarah, you made this kind of maybe a little bit harder than it really. No, consistency is all about consistency. All right, what do you think the first step is? What do you think the first step here is? Inverse tangent, get our angle. Awesome. Second step, we take our first angle and add or subtract pi. Probably just add pi. So we get our two angles. Whoa. We get our two angles. Unfortunately, the negative 0.32 is not between 0 and 2 pi. I wrote it in a different way right here. And I wanted to kind of talk about that. That notation is not an element of the set between 0 and 2 pi. So that's really saying the same thing. Just want you to see that. So what are we going to do with that? We just add the period 2 pi and we get a new number, represents the same position at 5.96. 5.96. And then we have our two values between 0 and 2 pi, and we are good to go. I also did it in degrees, so you can see that if you want. All right. So here's some extra examples. Extra cool. Feel free to have these downloaded, or maybe you could pause right now. They are two-steppers. Find the first angle, find the second angle. They all fit. Life's good. I drew a picture if you wanted, but you don't have to. So last one. I can change this range to whatever I want. Remember, I'm going to get my two critical values, and then I can choose to add or subtract the period to get it in or outside those ranges. So nothing changes with the process. That's what's key too. So this is a degrees, so I take the inverse cosine of negative 1/10. I get negative 95.7. That's certainly inside negative 180 to 180. Life's good. I find the second angle by, remember it's cosine, so I subtract it from 360 and I get 264.3. Darn it, that is not between negative 180 and 180. So what can I do with any of these two critical angles? I can add or subtract 360 to get another angle. I don't think adding 360 is really going to get me between negative 180 and positive 180. So I add or subtract. So in this case, I'm going to choose to subtract 360 to bring it between 180 and negative 180. And I get negative 95.7. So that is certainly between negative 180 and 180. If you're like, whoa, wait a minute, didn't he already get that? Yeah, it's kind of a cool thing to notice with cosine. With cosine, those are my two answers. This is a nice identity, you know, that you maybe use a little bit more and more. If you get one angle, a shortcut method to get that other angle is just make it opposite. You can certainly subtract 360 and get something that looks a little different, or you can do the opposite and it's the same thing. So cosine of 159 is equal to the cosine of negative 159. Very cool. All right. Hey, good job today. This is a topic that you want to be good at because everything else we do is solving equations down to this set and then going and getting the answers. So we're kind of looking at that. We're down to the easy part. Now it's like, okay, what do you do to go get the angles? So, all right, looking forward to it. See you later.